This is problem 6-16. We have a truss, and we're going to determine the forces in each member. And P is equal to 5. So this is 5 here. I want to start this one by solving for the reactions. There's a lot going on here, and it'll simplify things to have more information before we do the joint analysis. This will have, because this is a pinned, has to be axial. So we'll have one reaction going off in the same line as that. It'll have an X and a Y component, but it's only one unknown. Here we'll have a horizontal and a vertical. So I'm going to sum the moments about C. So if I sum the moments about C, I have the E in the X times 3, and that's going to cause negative rotation. And then P will be positive, so 5 times 4. The vertical reaction goes through C, so it doesn't matter. That's all we have. So EX equals 6.67. So that's going to be 20 divided by 3. So if this is 6.67, then these are going to be the same as the geometry. So if we look at this, it's 2 over 1.5 up. So 6.67 is to E in the Y as 2 is to 1.5. So EY equals 5. So this is 5. Now if we sum the forces in the horizontal, we got EX and we got CX. That's the horizontals we have. And EX is 6.75, so this is 6.67. In the vertical, we got 5 up, we got 5 down, so there's nothing left for this, so this is 0. Now let's redraw the truss. I'm going to draw it like this. Okay, here we've got 6.67 up, 5. We've got 5 down, and we've got 6.67 over. So there's the joint. Now let's erase the middle parts. I'll start here. So we have 5 down. If this one's going to go up, now this has a horizontal also. Now we know that these two horizontals have to be equal and opposite because they're the only horizontals they are. So if they're equal and opposite, because this has the same geometry as this, the ratio of this to this and this to this will be the same. So if these are equal, these are also equal. If these are equal, they must counter the 5. So together they add to 5 and they're equal, so they're each half. So 2.5 and 2.5. Now here we can do the ratio of 2.5 to the X component right there is going to be the same as the geometry. And the geometry in the Y direction is 1.5 and the X direction it's 2. So x equals 3.33. So this one is 3.33. And we have equilibrium. 3.33 to the right, 3.33 left. 2.5 up, 2.5 up, 5 down. So let's transfer those across, equal and opposite. And transfer these across, equal and opposite. Okay. There we go. All right, so let's look at this one next. We have 3.3 to the right. So we have to have 3.3 to the left. This has no horizontal. So this has to be 3.3 to the left. Now, all of these have the same geometry, so the ratio of the horizontal and vertical is going to be the same. So if this has 3.3 to the left, this has to have 2.5 to down. And now we have equilibrium in the x direction. So in the y direction, we have 2.5 down, 2.5 down, so we have 5 down. We must have 5 up. Take that across here. And we'll take this one across. So we got 3.3 here, going that way. We got 6.7 this way, so we have to have another 3.33 to the right. And even though it doesn't look like it here on my drawing, the ratio is the same, so we have to have another 2.5 down. And we have equilibrium in the y direction. So following that across here, 2.5, 3.3. So we have this one left. So we got 5 down, 2.5 down, 2.5 up. So we need 5 up. We got 3.33 and 3.33, so we have to have a 6.67, which is nice because then the 5 and the 6.67 has the same ratio, so the geometry holds true. And we follow that one across. And we're all done. So which one's in tension or compression? If it's pulling in, it's in tension. If it's pushing out, it's in compression. It's pushing out, compression. It's pushing out, compression. It's pulling in, tension.